We're going to do a little extension on absolute value functions and kind of play with them a little bit today. All right, so an absolute value of function is simply an equation that has an absolute value in it, and the x is inside the absolute value, or your independent variable is inside the absolute value. We have done some of these in the past, and when we did them, we noticed that they all looked like a V. In fact, we kidded around saying absolute value with the, the V. There are some parts. So I want you to look at this. What we've done is we've taken an absolute value equation, just a very simple one. F of x is equal to absolute value of x. And again, whether you write it f of x is equal to the absolute value of x, or whether you write it y is equal to the absolute value of x, it's the exact same thing. So what we've done is we've chosen some values for x. We substitute them in here, got the y value that went with it, and plotted the points. Now, there are some things on here that I need to show you. There is an invisible line that cuts right through the middle of our V. That is called our axis of symmetry. If I were able to fold this graph right on that line, the two halves of the V would lay right on top of each other. There is also a point right here. Okay, I made it nice and big right here, where the V changes directions. That is called the vertex or the corner. Okay, so we can find some things, and again, we're just playing with this right now. So my axis of symmetry is a vertical line. Vertical lines all use an equation x equals some value. And in this case, because it goes right through the center here, my axis of symmetry is x is equal to 0. The vertex is a point. Points all have to be written as an ordered pair, so the vertex is 0, 0. Remember, domain is what kind of x values. When I went to choose the x values here, there was no restrictions. And it looks to me like this arrow goes this way forever, and this one goes this way forever. So it looks like I can go out as far to the right, as far to the left as I want to with the x values. So my x values would be all real numbers. Then my range is my y. It's very clear to me that I only use the y values from here up. So I'm going to say that my range for this particular absolute value function is y is greater than or equal to 0. The x and y intercepts happen to both be at the origin. Let me erase this so we can see what we've got there. My x and y intercepts are both at the origin. And again, I can look at the graph and see that. They're both right there, so it's 0 and 0. Then I have two slopes here. I basically have two lines that have come together at that point. The line on the right here has a slope of up one, right one, up one, right one, up one, right one. So this has a slope of 1. This side is up one, left one, up one, left one, up one, left one. So this one has a slope of -1. That might be important as we move forward. Okay, now again, this is an introduction. We're not going to do a lot with this, but this is an introduction to absolute value functions and what you can expect. So we're just going to play with a couple of them. That's it. All right, so let's try this one, and let's look. The first one that I did was f of x is equal to the absolute value of x. So I want to look at this and then look at our new one and say what looks different here. Well, I've multiplied the inside by a 2, and I've put a -1 on the outside. So again, I can find all of that information that I found just a minute ago. It's all listed right here. But let's really look at what the difference is. My other V looked like this. Let's take a really good look at the differences here. It looks to me like this V, the red V, has dropped down one space. I'm betting that this minus 1 had something to do with that. So my vertex now is down here at 0, -1. Okay? I also notice that my V here is tighter. So instead of having a slope of 1 on this side and -1 on this side, I now have a slope of up 2, right 1, up 2, right 1, of 2 on this side, and a slope of -2 on that side. I'm betting this little number right here has something to do with that. Okay? Because of those two differences, then my information here has changed. My axis of symmetry is still right down the middle. It's still x equals 0. Again, my vertex is at 0, -1 because it shifted down 1. My intercepts here are now at +1/2 and -1/2 for my x-intercepts. My y-intercept is right here at -1. My domain continues to be all real numbers. My range is now from -1 and above, and then the slopes are different. Okay, let's look at this. Oops. This gives us kind of like a chart that tells all the differences and what happens. Okay, this is what I would consider a format for an absolute value. Now you'll notice I can have numbers inside here added or subtracted. I can have stuff added or subtracted on the back. I can multiply. So they're letting this be the A value. So little things. Okay, and we're going to play with this. So if your A value is positive, your V is going to open up. Okay, so if there's a number on the outside of your absolute value that's multiplied, if it's positive, it's going to open up in a V. If it's negative, the V is going to open down. Okay, your B value is inside the absolute value with your X, and it is basically subtracted from your X. Now, this is the tricky one. This is called your horizontal transition. This is going to slide the V left or right. It slides it the opposite way you think it would. So if this was like -2, you would think it would go 2 places to the left. It actually goes 2 places to the right because of the minus sign here. Okay? So you can see here, my original one is in blue, and that's just my parent function. My f of x is equal to absolute value of x. If I put a +2 in there with it, it slides the whole v to the left 2 places. If I put a -2 in there, it slides it 2 places to the right. Okay? The width also depends on the A value. Now, that A value on the outside can make it steeper. So remember, with slopes, the larger the number, the steeper it is. The smaller the number or the closer to 0, the flatter it is. Okay? Now, that actually can happen with the A value on the outside, or if I were to multiply the X by something inside here, that also can change the slope of the lines. All right, and then the C value, and you'll notice that the C value is what's tacked on the end, either added or subtracted on the end. That is going to be my vertical translation. That's going to slide the V up or down, and that does exactly what you think it would do. If you put a +2 there, the V slides up 2 places. If you put a -2 there, the V slides down 2 places. Okay, and that's it. Play with your calculators on those.